Awesome. And now we're live on the YouTubes. All right, pretty good. Okay, welcome. Today I'm continuing work on, as I wait for YouTube to get going. Today I'm continuing work on a 2D physics game we started a couple of streams ago. There we go. Awesome. And let's quit that. Let's quit this. Let's quit this. Oh, let's say that we're live. And we're live. Working on 2D physics game. Impromptu stream. Awesome. Okay, so we started work. Let me fire it up. I can show you what we've done, what we've accomplished the past couple streams. We have built fun, little derpy, silly 2D physics game. 100% open source and 100% on stream. So it's only taken us a couple of streams. I think we're on stream number 6, I believe. And the goal is to get 100%. Yeah, so here we go. We got our thing. We can pause the animation. We can build little contraptions. We can put a spring right there. Spring, thank you very much. Yeah, so we can build little contraptions and little devices and little stuffs, which is pretty fun. The goal, if we can make it happen, is to get this thing 100% finished and submitted to the App Store in 2 weeks. We are almost 1 week into that process, and I think we have a pretty good prototype, pretty good demo going on. So I think the next steps are to tidy up the interface a little bit, the user interface, make it a little bit easier to use, a little bit easier to build stuff, a little bit better graphics, hopefully some nice sounds, sound effects, that sort of thing, and get this thing submitted. I think that would be awesome. But yeah, so far 100% of this has been done on stream, and 100% of the code is available on GitHub. So you can look either on screen right now, remote. There, that is the repository name for the code. I changed the repository name from last time, but everything should still work just fine. You shouldn't notice or need to change anything. But yeah, you can download the code and follow along or make changes or do whatever you want. But let's work today just a little bit, a short stream today, and work on tidying up some of the interactions. Now, the way it works right now, which is fine for the prototype, is you click to drag to create things. And that's fine, but the only way to modify any of these points is you click on this move point tool, and then you actually have to drag just that one point around. You can't, and even then sometimes it sticks, but you can't click on a line and move the line. You can only click on a dot and move the dot. And what I would like to do is also support clicking on any of the pieces, any of the parts that are on screen, and dragging those around too. And I think that should be something that's a nice, concise thing that we can get done today. But before we do that, we ran into a bug at the very end of the last stream that I would like to take a quick look at. So last stream, Nix, it is Objective-C. Everything's Objective-C. I haven't made the dive into Swift quite yet. From the people I've talked to, it's the specification is still moving for Swift a bit too much, and it's just not something I wanted to deal with. All right, so this instant pan gesture versus the UI pan gesture. So we talked about that. We did that a little bit last stream. The issue with the pan gesture is that the pan gesture, if I move something around, if I pan, I'm clicking the mouse and I'm moving it around. If I pan, the pan gesture only decides that it activates after I've already moved the mouse or the finger after a certain distance. So that 30 pixel difference might mean that I end up missing the dot, like that I'm suddenly too far away or a lot farther away than I thought I was, so I don't grab the dot, which makes for a really annoying interaction. We fixed it when creating everything. We actually save the original touch location, and I can show you that here. This guy just extends. This is a very simple class. We extend the pan gesture recognizer, and when the touches begin, we save our initial location immediately. And I think the issue is that we're running into. So let me run this and show you the bug that I think is the problem. So if I hit move point and I drag that guy around, I believe the next time I try to drag something around, yeah, you see that? So there's the top left corner. If I grab the top right corner, it's actually grabbing a different corner. It's grabbing a different thing altogether. And I think the issue is that we are setting our touch location after touches began. And what we want to do is set it before, I think. Touches, any object, location in view, nil, sending nil ends up using the window. And I think that will help us. Let's try. The other thing that might be the issue if it wasn't this, when the grab point gesture is activated, it looks at a grabbed point, right? Yeah, and so we might need to update when we set this guy to be set or reset. But let's give that a try real quick and see if that fixed it. You can also see it really easily if we create a bunch of different pieces and then we move this guy around and then move. Yeah, see, I keep grabbing the same one even though I'm trying to grab a different one. So my grabbed point, this guy might never be set. Is that what's happening? So he's set, which is fine. Yeah, so it's still grabbing him. But if you noticed it grabbed it after it moved, and so it updated beforehand, which means, what does that mean? Does that mean we never end? So if we end, that should be nil. Oops. So let's look. Let's see what happens now. And I might, instead of breakpoints, I might put some logs in here in a minute. Stick. Oops. Let's pause the animation. Stick. 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 So it's really what we're building here is just a super simple 2D physics engine using Verlet integration, which I had never really played around with before this project. Yeah, that looks, just resetting it to nil. Looks like that did the trick. So that's good. Awesome. So now we can grab things a bit more consistently. Well, I say that and then I can't grab that one. But I think we are. I think we are a little bit better. Okay, cool. Yeah, it just uses something called Verlet integration, which we did in the first stream. There's a sub repository in here as well, the coding math sub repository, which is right there on screen. He has a couple different YouTube videos where he goes into it in detail in JavaScript code, and we started this project porting that JavaScript code. It's maybe just like 50 or 100 lines, super short, and it just made it really super, oops, wrong button, ridiculously simple physics integration, 2D physics thing. So yeah. Today's goal is to be able to not only grab dots, which we can already do, but to be able to grab the lines themselves and the pieces themselves. But first let's commit that fix real quick. Pan gesture delay. Awesome. Push that up. So the other thing that I would like to fix is, I'm going to see if I can show it, if there's a good way to show it. So if there are 2 points very, very close to each other, no, those snapped into each other. Yeah, so those are close to each other. I believe it's always going to grab this one here on the right, even if I try to grab the one on the left. I'm here closer to the one on the left. Oh, it grabbed the one on the left. Never mind. It's always going to grab one and never the other one. It looks for a point that's within 30 pixels. Yeah, there I grabbed the second one. It always grabs a point within 30 pixels, but not necessarily the closest point within 30 pixels. And so that's what I'm going to fix here. Get point near. It's filtering all of our points for things that are less than 30 and then just grabbing the first one. But that means if two things are less than 30, the closest object might not be the first object because these are not sorted at all. And so instead what I want to do is if we do a sorted array using a comparator, right? Then we can return the first object of that sorted array instead, right? There we go. NS, let's do NS ordered. There we go. All right. Okay. Points, bad receiver type. Oh, sorry, not sort using comparator. I wanted a sorted array using comparator. I wanted that guy. Yeah, that's what I wanted. Okay, cool. And so then we can put in our distance from point. That is, those are CG points. So we want obj1, obj2 dot as CG point. There we go. All right. So we return if it's less than 30. Actually, we just want them sorted by their distance from the point. Man, I am just I am going everywhere. So the distance from point, not to each other. Oops. If the first object is closer than the second object, that's what I want. NS ordered ascending, otherwise NS ordered descending. And I always get these mixed up, so we're just going to test it and see which one works. Right? So now we should always get either the, yeah, it looks like it's always getting the furthest point. And we're also not filtering it if it's close enough. So if point distance, oh, I don't want. If the distance from point is less than 30, then we can return it. Otherwise, we can return nothing. All right, that's better. So now it's either going to get the furthest point with a distance of 30, or it's going to get the closest point with a distance of 30. And so if I go here, is it going to snap to, yeah, snap to that guy, which is good. Snap to that guy. Oops. Yeah, so it's snapping in the correct direction, so that's good. So that means now this guy, if I grab here, it grabs the middle one. If I grab a little bit to the left, it grabs the one on the left. So now they're sorted really nice, which is good. And those snap together, which is a problem. Cool. Awesome. So that's nice too. So that fixes our just a little bitty clean up things to get us warmed up. Grabbing or snapping to closest point. Great. And so now the next thing that I want to do is figure out how we can grab sticks instead of just points. So let's look at how we've got that set up. We have it set up with the best place to learn Objective-C for a beginner. That's a good question. So a place that I think is really underutilized is the WWDC videos that Apple puts out. I think those are fantastic. I would definitely look through those and look through a lot of their sample code that they provide. There's some really good projects and good sample code. I always learn the best by getting somebody else's code that works and then mucking around with it and just trying stuff and deleting lines and changing values and just playing with stuff just to see start tinkering and seeing how things work. So that's what I would do. I would go look for Apple sample code, download it, get it running, and play with it that way. There's also a few good books that if you're a book learner might be okay, but that's what I would look at. So let's go here. I want to look at the grab gesture and see how that guy functions to see where we need to plug in to grab sticks as well as lines. Move point, right? So here's our gesture that handles what we grab. You can kill, do we need that guy? Yeah, that guy can actually go inside of there because he's not used outside. Okay, so what we do here, let's look at our screen and figure out what our basic data model is. Right, so we have sticks, we have pistons. Right, I'm going to make this point immovable and this point immovable, so they're just stuck to the background. Make this point immovable. We have springs, we have engines, we have a balloon, and we have wheels, right? So that balloon and that guy can snap there. So those are all the different things that we have. You can see the piston moves up and down by itself. It's powered. The spring is kind of stretchy. It's basically an unpowered version of the piston. The engine has a point that moves, kind of oscillates inside of it, back and forth. So it's kind of like a piston, but it's a fixed length. The balloon, it's hard to see here, but it floats, so it floats up. And the wheel just has a bunch of different points, and it's easy to move around. So those are all of our things, and they are all essentially created with one of two things. They're created with the little red dots, those are points, or they're created with the blue lines, and those are sticks. So all of the physics, all of the stuff that we're doing just revolves around either a point or a stick. It's one of those two types. And right now, we only care about grabbed points. And what I think we want to do is also handle a grabbed stick, I think is the right thing. and it can be either a grabbed point or a grabbed stick. So if this move point begins, then I look for our location and I get a point, get whatever point in our data structure is closest to that. And so if I basically mirror this, and if I get stick near and a grabbed stick, right? And if grabbed stick, I'm just doing pseudocode. This won't compile, obviously. Then we want to nil out our grabbed point because we want the stick to take preference over the point. No, I think we want the point to take preference over the stick, right? And I say that because if I grab this endpoint here, then that's also close to the stick, and I don't want to grab that stick. I'm really trying to grab the point. But if I'm here in the middle, I should still grab a stick, right? So if I have grabbed a point, then I need to release that. So maybe only look for a stick if I've not grabbed a point is a better way to think about it. And then now, as I move around, I want to as I move around the point, then I'm going to want to move the point if I've grabbed a point, or I want to move the stick if I've grabbed the stick. So let's go ahead and implement these two things right here, the grab stick and the get stick near. Let's put that up here first. Grabbed point. So this is going to be a stick. All right. So this is stuff for the move gesture, right? Toggle running the simulation or not. On off. Stick that's currently being made, which is fine. Okay, so now the grab stick, let's come back down here. We want get stick near also, which we're going to put down here. Very similar to get point near. We want mm stick. Get stick near CG point. Point. Awesome. And it's actually going to be very similar. It's going to be very, very similar to our get point near object, except this is going to iterate over the sticks array. And it's going to look for sticks. And sticks do not currently have a distance from point, and so we need to add that to our stick object. We want distance from point, CG, oops. There we go. And I'm going to have to look up a little bit of code for this, but we're going to worry about that in a minute. Right now they are all too far away. That's fine. To fix this, right? The other thing I want to look at that I didn't actually see, let's make sure we compile. We should compile. Okay, great. And now we want to get the stick near. So this should always return nil because we just defined this as always being 100 for sticks, which is fine. Now the other thing I want to look at is I forget what happens actually for updating the point when we're moving it around with this pan gesture. So if the state begins, we do that. If the state ends, we do that. What do we do with this if just during the move, right? How do we handle that? So create wheel. I want to go look at I should really remember how we did that. So let's go up and look at our initializing method. Grab point. Let's look at where we do the grab point anything. Oh, you know what? You know what I think it is? It's here in the enforced gesture. That's an interesting way to do it. I think that's probably the right place to do it. Yeah, that's a good way to do it. Okay, that's interesting. So what this does, this enforced gesture, let me show you where that's called. That's called in our run loop. So this is our animation loop. So every frame, this guy is called. We clear the screen, we update our physics, basically. This guy makes sure our physics are valid. So this can put, after gravity and all the forces and movements and everything else, might put our system in a obviously incorrect state. Things might be off screen or that sort of thing. This enforces various things. So this enforces collisions and bounces and all of that, and also our gesture. And then we remove broken sticks, and then we render everything. So this guy is just if we've happened to grab something, then it just hard codes it to the location and then nulls the velocity if it needs to. And so what we need to do here is else if grabbed stick, but we can't we can do some of this. So oh yeah, if it's not on, then we null the velocity of everything. That's fine. We null the velocity of the entire animation. That's fine. So here we can set the point to the exact location of the touch. But if we're dragging a stick, if I drag it here, if I grab it here, as I drag it around, I would like to always be holding that piece, right? Which means I need to know how far away the right-hand endpoint is, how far away the left-hand endpoint is, and really also what the angle is in either direction. So I need to save that information somewhere. So the way I think we're going to save that is the grabbed stick. We also need to save where is our thing? So the grab stick, we need a point, and this is a grab stick offset P1 or P0, and an offset of P1, right? And so as I click here, the offset for P0 is going to be mostly X, like say negative 100X, and the offset for P1 is going to be about 40 P1, right, for P1. And so then as I drag around, wherever my point is, I can then calculate the new offsets for the stick based on those two offsets, right? So that means this guy here can be in, where is our gesture, our move point gesture? So when I grab the stick, the grab stick P0 is going to be the current location dot x minus the grabbed stick dot P0 dot x. Does that feel right? I think that's right. I think we can do it from that. And same thing for the y. So this is the offset for the P0, and then we'll do the exact same thing for P1, right? So now to get our location as we're dragging it around. So as we drag it around, we can take this offset and add it back into the current location, and we should be able to calculate our new endpoints, right? So that feels pretty good. And so then down here in where was it? Not the get stick near, but the enforce gesture. That's what we want. So we want grab stick dot p0 dot x is equal to this plus our offset, and then same for the y plus the offset y, right? And then we do the same thing for p1, and I think we're good to go. The only thing we need to deal with now is this distance from point, right? And so now what we need to do is we need to figure out how to calculate the distance of a line segment to a point. Let's do that real quick. Let's actually, what we're going to do is we're going to return 20. We're just going to say that the line segment, every line segment is within range of our gesture. We're going to clear it, turn the animation off, and make a stick. Right. So now, because we hard coded it to 20, I just want to make sure everything else is working, and then we can debug and fix this distance method. But since we only have one line, the fact that every single line is going to match our gesture doesn't matter. So if I click here and start moving around, that did not work at all. If I click here, that did not work at all either. So now let's look at physics view. Can we move it? But let's set a breakpoint. Right, so we should have grabbed point. We should have a grabbed stick, which we do. Grab stick P0. Oh, no. Sorry. I flipped the wrong sign. No wonder it was broken. So this part, I think, is correct. We might need to do that, which will flip the signs, but that's fine. So we want it in force gesture. That's what I was trying to do. I wanted to flip this sign right here. I think that's our issue, right? Okay, so P0 is on the left, P1 is where we lift up. Turn the animation off. So now the offset to P0 should be like negative, I think it should be like negative 40, because I picked it up mostly on the left-hand side, and the offset to P1 should be like positive 200. Is that what we see? So it's not negative 40, it's positive 40. Yep, so that means this didn't need to be negative. So now my grab point is here, minus a positive 49 is great, and then minus a negative. This should be a negative. Oh, that's the other problem, is I didn't do that. I was using the wrong variable, and that's a negative. Yeah. Okay. Cool. So we're doing a couple things wrong. Awesome. So now this should be. Now we should be able to grab the stick correctly, and we can. Awesome. That's great. But it's always updating to the old offsets, which is interesting. So that means these here should be move point gesture. So here we want the grabbed stick equals nil. We didn't reset that one. That was the bug that we just ran into with the points that we fixed at the very beginning. And now that we fixed the one with the points, we know how to fix the one with the sticks, which we just did, because we're amazing. Okay, here we go. Move points. If I can grab it midair, I can, and we can move it around. That's awesome. Cool. So now we can grab sticks. Great. But what we need to do now is we still haven't actually fixed this distance from method. We need to make sure that works. But let's commit our progress so far, because I like to overcommit. We can grab sticks, but right now we grab every stick, right? That's our problem. So we need to fix that. So that code is actually, I'm going to look it up in another project. This is my other app. It's currently in the App Store, and here is our code. Great. So this is nearest point online, I think is what we want. Yeah. And just this code will find what we want. Let me show you what it's calculating, and then we will use it. Rel. Yeah. Yep. Yeah. Okay. Cool. Cool. So what this is going to do is this is going to let us, I'm going to put this guy right down here, and even though he's below, yeah, great. So that's our point, and then our segment is self.p0.as cg point and self.p1 as cg point, right? Point on line. This is not the point on the line segment. This is just the point on the line. Yeah, still got a little bit more to go. So this is just the point on the line, not the point on the line segment. You know what? I don't actually want to run this. We're just going to stop it because we have what we need. So what that guy's going to calculate for us is if this is our segment and this is our point, what we need is we need that distance, right? Where it's the distance to the line segment. Because if I'm dragging out, that's what I care about. What it's actually going to it's actually going to calculate is that right there, right? It's going to calculate this distance, this perpendicular distance to the line, not the distance to the line segment. But that's okay because now we can see that this distance from the point it found to the first segment endpoint, and this distance from the point to the other line segment, the sum of those two distances is greater, much greater than the distance of the line itself, right? So we can just detect that. So we can say, let's do if self.p0 distance from point is from the point it found plus self.p1 distance from the point is greater than, or rather if it's less than, right? Self.p0 distance to self.p1.as cg point, right? So you see what I'm doing here? This is if this distance, the distance to the two endpoints, is smaller, less than or equal to, rather, the distance between the line the length of the line segment. If it's less than or equal to that, then I know that I have found a point inside the line segment. That's what I want. Otherwise, I have found a point outside the line segment. So this is the So this distance, so the distance from point to point on line is the distance to the line, right? And this is important. So that means we can say, we can return, we can just calculate self.distance calculates 2 CG points. Okay, is that not public? Let's make that public. If it's not. There we go. We have a lot of distance methods. That's ugly, but whatever. Too bad. So if that's true, then we can return. Was that a class method? No, of course not. It is now. Because it doesn't use self at all. It really shouldn't be a... it really shouldn't be a instance method. It should be a class method. Cool. Right? So this means we find a point on the line. If that point lies within the line segment, then we know that the distance of the input point to the line segment is that shortest perpendicular distance. So we can just return the distance. Otherwise, we know that we're in this case where we want the where this is our line segment, and we just clicked out here, and that means this guy, that distance here is our shortest distance to the line segment, even though this distance is the shortest distance to the line, right? So what we can return is we can calculate the distance to each endpoint in the line segment and return the smaller of the two, and that will be the smallest distance from the input point to the line segment. So we return the minimum of the point to self.p0 or p1. Right? So now we've returned the smallest of the distance to either it or its line segment. Right? So now that should let us calculate the distance from the input point to this line segment. Right? Turn the distance from the input point to this line segment of P0 to P1, right? Awesome. That should work now. Hang on. Okay, so now that should be everything we need. We've calculated our distance correctly. Let's make sure we have our get the stick near this distance. We're sorting sticks correctly. We only care about sticks that are within 30 pixels of the grab point. Otherwise, we don't return a stick. So now we should be able to grab any stick in the simulation. Grab the right hand side. Yep, we can pick up the right hand box. We can pick up the center of the box. We can pick up the left hand. Can we pick up the left hand side of the box? It grabbed a point. That's not what we want. There we go. Now we picked up the left hand side of the box. Awesome. Awesome. That's pretty great. That will make things a lot easier to edit when you can just grab the point, and you can also grab the point here. Move stuff around. That makes stuff a lot easier. So points then take precedence, which is good. I'm going to draw a 30 pixel radius around the points just so we can see how big that is. We might drop the point grabbing down to 20 pixels now that we can grab lines, because we might just end up grabbing points too often. So let's go here into points and go into our render method here. Let's do this. Let's make a red line with a radius of 30. Great. Do we have a constants file yet? Constant? No, we don't. That's fine. Maybe we'll make one. So now we have a red, oops, sorry, a dot. There we go. Dot stroke, not fill. There we go. Okay. So now we have a 30 pixel radius. Does that feel like it's too large for moving points? For grabbing a point? I think the Apple Hig says a 40 pixel button, which would be a 20 pixel radius for buttons, at least 40 pixel by 40 pixels. So that might be a little big, but we'll keep it for now and just and think about it. Let's go git status, git commit. We can grab sticks and points. Great. Oh, come on. We can grab sticks and points. Awesome. Cool. So you can get that code again right there. It's on screen. It's also in the description, or it should be if it's not. But you can download the code. Everything we're doing today is open source, and everything we're doing is also going to be shipped to the App Store in a little over a week. That's the goal. We're on day 6. Day 6 of a 2-week adventure trying to build a 2D physics game in only 2 weeks. I've never done this before. I've never played with 2D physics, and I've never made a game, and I've never shipped something to the App Store in 2 weeks, and so we're going to see if we can do it. So this is where we are on day 6. We have sticks that we can create. We have pistons that we can create. We have springs, which are like wobbly sticks that we can create. We have engines, which have, let's put a spring between that, and that wobbles back and forth. And we have balloons and wheels and all of that stuff works. And now we should also be able to grab sticks, which is pretty great. How ridiculous is that? Cool. So now we can build some pretty cool contraptions. We can grab sticks a lot easier, so we don't have to care quite as much about where we grab. We can just pick things up and toss them around, which is great. So I think we're really in a pretty good place now. I think maybe next stream we'll start working on the UI a little bit more. I'd like to get rid of all these different buttons, which are pretty awkward here at the top. So maybe we'll work with that, or maybe we'll work on rendering. Really not sure. But the website for this project is in the description if you want to check it out, if you want to follow along. All of the previous streams are up as well. I'm recording everything, so all of the code in the app is done on stream, and so you can go back and look at how we've built really everything from day one. You can see every line of code and where it comes from and why. Yeah, thanks for coming out. Check out the website. It's sparepartsapp.com. And you can see the streams. You can see the code. What else? I think that's it. I think that's all I got. Short stream today, but we got a lot done. You can grab stuff. We can toss stuff. This is awesome. I'm liking where we're at. We made a lot of progress in 6 days, so I think we're doing pretty good. But we'll do UI hopefully tomorrow, maybe on Monday. We'll pick it up, and we'll go from there. But thanks, guys, for coming out to the stream today. Let me see if I had anything on YouTube. Nope, no comments or anything. Cool. Thanks, guys, for coming out, and I will see you on Monday. Thanks, guys.